Here are 7 tips for using behavioural data, brought to you by me, Ray Poynter. So I'm going to start off very briefly by describing what behavioural data is, and then I'm going to share the 7 tips with you, and then I look forward to Q&A. So what do I mean by behavioural data? It's data that describes what people do, and in the typical form that we get it in the insights and research industry, it's data that does not depend on people's memory. So it's web data, for example, pages viewed, links clicked, search words, ads, all of these sort of things collected automatically by the web server, collected by the browser, but not from somebody's memory. The digital wake that we all leave behind us, so mobile phone usage data from the mobile phone companies, from mobile phones, from the cell towers, the use of cash machines, payment systems, transactional records, the Wi-Fi connections as phones go past different connectors and connecting to the Wi-Fi system, messages and email data. All of that is part of the wake. We also have meter data, so how much energy is a house using? How much energy is a building using? What is the footfall through a shopping centre, counted electronically or digitally? What are the traffic flows up and down roads, counted digitally? All of these methods are behavioural data. So is social media, so Facebook, Instagram, Pinterest, all of these. How many people are posting? How many people are clicking likes? What sort of things are people posting about? We're collecting all of that automatically. We're observing what they do. Biometrics, so the use of smartwatches that collect how many steps have we taken, how fast has our heart been beating, where have we been geographically. Health apps going even more into the detail about what the body is doing. We can find records in Strava that record the activities, the exercises that people have been taking and who, in many cases, they've been taking the exercise with. And there is observation data where somebody is actually sitting there and watching. So this would be more like an ethnographic study. So this is still behavioural data. We don't have the memory or the judgment of the person being observed, but of course we do have the judgment of the person doing the observing. So that's our behavioural data, and here's the first of the 7 tips. Think about what is included and think about what is being missed with your data. So do you have unwanted items in your behavioural set? So for example, if we've got web data, does your data include people from other countries? So if we're talking about visitors and we're trying to improve the service for our potential customers, we don't really want to include the data from people who are visiting from other countries. Do we have non-customers? Worst of all, do we have bots? So when we're looking at those social media posts, how many people clicked like? Was it people, or have we included bots in the mixture? So that's where we're trying to make sure we don't have data that is not from our target group in the data set. The other side of that coin, who is not included. So if we look at mobile phone data, there's often a very big split between the pay-as-you-go people and the contract users. You may find that you've got great data about the contract users, but very little data about the pay-as-you-go users. And there are some really interesting differences between these two groups of people. People who spend cash, and then people who pay with their cards, and people who pay digitally with their phones and their smartphones. Maybe you've got some of those types, but maybe not all of them. What about the non-loyalty card people? Loyalty card data is a fantastic resource for looking at the behaviour of people when they're shopping. But it doesn't tell you anything, of course, about what non-loyalty card people are doing. What about people who have not registered to use the service properly? So around many of our cities, we see lots of use of e-scooters, the publicly available e-scooters. But in the UK, there are also, for example, a lot of private, unregistered, illegal users of e-scooters. So we're going to miss those people if we simply look at all the data from the official e-scooters in terms of how many people are using them, what the typical journey length is, where those journeys are. So this is a nice example from the Second World War about thinking about what was being missed. So they looked at the planes that came back and they looked at where all of the bullet holes tended to be. And this was an example of a chart which has been mocked up to show here are all the places where the bullet holes were. And for a short amount of time, the people running the program said, we better reinforce all of these areas because this is where the bullets go. Luckily, they stopped and had a think because actually all of those areas that are not coloured in red are the places where if a bullet hit, the plane did not come back. So looking at the planes who came back is a very poor way of assessing where they should be. And this is called survivor bias. It happens in data all the time. If we just look at the cases that come through, we're missing why other cases did not come through. So tip number one, think about what is being included. Are some ineligible cases being included? And the second part of that, are there people who you are missing? The next thing we have to do, and number two, is define the granularity of the data. So is one data source the same as one person? So I'm looking at what you ate today, and I'm looking at something, the restaurants, perhaps you've been paying in restaurants, we've been collecting that information. That's fine. But sometimes we get multiple sources for one person. So you've got more than two phones. So if I look at your phone data, I'm not picking up the whole story about you. It's even more true with multiple browsers. I have two browsers on my phone, I have two browsers on my iPad, and I have three browsers on my laptop. I can look like 7 different people. And that has got a challenge for the granularity. I might have multiple profiles. In fact, I do. On Facebook, I have 3 profiles. I have one in English, I have one in French, and I have one in Japanese because I'm trying to practice some language skills. So there are multiple me's out there in social media and in other places. We also sometimes have one source leading to multiple people. So any data about households, the energy consumption per household, the water, in some cases, the viewing, streaming behaviour of the household isn't going to break down into individuals unless somebody lives on their own. Also, we need to think about the units. And this comes back from a study I was doing many, many years ago with a pharma company in the UK. And they passed me some data and we were looking at shipments to and from supermarkets. And I just looked at the data they'd given me for tampons and did a quick bit of mental arithmetic. And they were claiming that their shop, which has got a very good distribution around the UK, was selling enough tampons for every woman in the UK aged between, let's say, 16 and 50 to be using 50 tampons every single day of every single month of every single year. So we looked at what was going on, and somebody had conflated the data, which was for individual items, individual tampons, for cartons. Cartons are boxes of tampons. And they had multiplied through twice and had come up with this enormous number. So whenever we're looking at something, we want to know, is it in seconds or is it in minutes? Is it in pounds or is it in dollars? Is it in units or is it in containers? All of this is really important with the behavioural data. 3, this is a really important one again. What is not why. So it's fantastic with behavioural data that we get lots and lots of what is actually happening. But not buying something, not choosing it, not using something doesn't mean that it's not wanted. There might be barriers to actually using it. I might really want an electric car, but my neighbourhood maybe doesn't have charging facilities. I would like to be using a new type of cooking pot, but my house doesn't have the right sort of hobs in it. So we always need to be looking at the observational data and thinking there could be barriers to why people are not using something. Doing something regularly doesn't mean that people want it. And I see this quite often where people talk about loyal customers. They're loyal customers because they spend nearly all their money or they spend nearly all their time with this particular provider. But maybe they are the only store in the neighbourhood. Maybe there is a credit tie-in. Maybe these people have signed up to a long mobile phone contract and they can't break the contract. These aren't loyal customers, they're hostages. And you can't tell the difference just from the behavioural data. So the member checking method is the gold standard. Ask people about why they're using it and why they're behaving the way they do. But don't always assume they can and they will tell you why they are actually using it. They may not have access to that, or there may be social desirability bias around why am I using this. Causality is often, I would say perhaps even usually, difficult to establish from behavioural data. Sometimes it's not so hard. So I've looked at over the years quite a lot of data around cities, and we see a switch happen. When the weather is bad, people switch from bicycles to other transport. So they start using public transport or cars. It's clearly not that the switch from bicycles is causing the weather. And it makes good common sense that the weather changes are likely to get people, when the weather becomes bad, people are less likely to ride their bicycle. So that we can feel reasonably comfortable with. In fact, in many cases, when you look at it more closely, it's the weather forecast which is a better determinant of whether people are going to switch than the actual weather. But there are a large number of cases, and there's a very famous one which looked at hormone replacement therapy and heart problems. And what they found was that women in the United States who had been prescribed HRT, this is a long time ago, 40 years ago, were getting better outcomes for cardiac problems. And so they got to the point of prescribing HRT, not just for problems around menopause and so on, but also as something to help the heart. Only later did they do a better study where they discovered that actually it was marginally bad for women's hearts. The reason it looked good was that the women who were being prescribed HRT tended to be middle and higher income. They tended to have regular meetings with their doctors and therefore had better outcomes compared with the rest of the female population their age in the country. So the causality of these better outcomes was having a better standard of living, having medical treatment. It wasn't being caused by the HRT. So ideally, we want to create randomized control tests. We can't always do that. So as Julia said in the NetQuest presentation that you saw a few minutes ago, we're looking for natural experiments where we can see where people have fallen into different categories, not through choices, because of course that would lead to more bias, but through some other phenomenon. And we can use that to try to establish causality. So here is a nice example of what I'm talking about in terms of causality. This was from a presentation I saw many, many years ago from an insights manager. And he was talking about how he had been approached by the social media marketing person to say, we need to keep more spending on social media because the blue bars on this chart are the amount of money we spend on social media advertising, and the black line are the sales. And when we increase the spending on social media, we increase the sales. And when we drop the expenditure, the sales drop. So we should keep increasing it. And the insights manager took out his Sharpie and they scribbled onto it, winter, summer, winter. So what we saw in this case was the summer increased the sales of ice creams, and the increase in the number of people looking to buy ice creams increased the spending on social media, which was aimed at moving people away from one brand to another brand. And in the winter, fewer people are buying ice creams, so there was less social media advertising. In fact, the sales were driving the advertising budget, not the advertising budget driving the sales so much. Here is another nice example from one of the companies I was working with a few years ago. And in the first region, let's say in January, they indexed the sales at 100. And in the second period of time, let's call it February, they added some TV advertising and it took the sales to 110 on the same index basis. And in March, time period 3, they added Twitter and the sales jumped to 130. So the very simple understanding of this would be, adding Twitter is twice as good as just TV on its own. But in region B, they did the same experiment the other way round. Indexed the sales in period 1. They did Twitter first in February. Sales went up 10%. And in time period 3, with TV and Twitter, the sales went to 130. So now it looks like we have a combinatorial effect. 1 + 1 = 3. However, in the third region, they ran no advertising. And the sales went up from 100 to 105 to 110. This is what we call the counterfactual. This is what would have happened anyway. And when we're trying to look at behavioural data and isolate causality, we really want to be able to do these sorts of experiments to say, what is the counterfactual? What would have happened? And then can we do the changes in different orders to give us a better understanding of what is going on? The fifth tip refers to something that I call the lamppost phenomenon. And so you go into the car park outside the restaurant and there's somebody looking under the light. So you ask them, what are you looking for? Oh, I'm looking for my car keys. So you say, well, why are you looking for the keys under the lamp? Is that where you lost them? And they turn around to you and they say, no, but this is where the light is. And I see this all the time when people are looking at the data they have. They have some crude demographics from things like Acorn data, and they're trying to explain the behavioural and motivational reasons why people buy the brands, because they've got sales data and they've got addresses and therefore they've got some information. But it may be that that information does not explain the outcome. I see it in quite a few other situations. Social media is a classic one where we find time and time again, people are taking Twitter data because it is so much more available and trying to use that to explain the outcome. And sometimes it really won't, because it's only like 15% of everybody, and it's only those things they're willing to talk about. So be careful of the lamppost phenomenon. Because you've got some behavioural data, it doesn't mean it's the right behavioural data. When we're working with behavioural data, you want to make the patterns easier to see. The biggest problem in many ways with behavioural data is you've got too much data. It is too granular. It's about too many people and too many situations. So transform the data. Look at it per person, or index it, or maybe you want to use log scales to make the data stand out better. You want to check for outliers. Is there some data in there which really shouldn't be in that case? I remember doing one study and we were looking at sales of analgesics before and after a change. And we had all the sales data from the pharmacies and chemists. And one particular place had changed its sales massively. And they had had a major golf tournament in the town. And that had changed the sales of everything, not just the sales of the analgesics. So it was an outlier. Sometimes you want to recategorize the data. And we're seeing this a lot in the social sciences as well. So we have people who are married 0 times, once, twice, 3 times, 4 times, 10 times maybe. And that can really be hard to interpret. If you recode that data, people married 0, people married once, and 2 or more, you will often have clearer data to work with. So think about recategorizing your information. So here's one example from a piece of work that I did as part of my storytelling course. And I looked at Gapminder, and we're looking at spending and child mortality. And there are lots and lots of things that are done here in the style of Hans Rosling. So the first thing is we've categorized the regions by colour. So red is Asia Pacific, yellow is Europe, green are the Americas, and blue is Africa. And the size of the bubbles are the population. So that's the data you get very quickly from Gapminder if you're using it to analyse it. Along the bottom, we have child mortality, deaths under 5 per 1,000 births. Because, of course, big countries have more deaths than small countries. So if we want to be able to look at those countries comparatively, then we need some sort of unit, and deaths per births at some fixed age, so under 5. And on the vertical axis, we've got health spending per person. We want it per person because otherwise the big countries are going to be spending more than the small countries. And if you have a look at it, this is a log scale because that is what tends to happen with spending. Very often, if you're looking at spending, you're going to want to use a log scale to make the patterns easier to see. And then we've added a line through there to highlight that for the vast majority of countries, the amount that they spend is very linearly linked with the child mortality, deaths under 5. So we can see that pattern there. Is there a causal link? There are other things we would have to investigate. But of course, we might well feel there was a causal link as part of that process. This is some more grim data. This is from the COVID problems. And this is data from the UK, and it's actually from March 2021. And we're trying to make sense, looking at that data, of the number of daily deaths. And it jumps all over the place. In particular, far fewer people appear to die at the weekend. Now, of course, that is not true. Far fewer deaths are recorded at the weekend, and there tends to be a jump on Monday and Tuesday, and it comes right. So the data becomes a lot clearer if we add a moving average, but it has to be the right moving average. If we were to use a 3-day moving average, we actually end up with something which is even spikier and harder to read than the raw data, because 3 does not play well with 7, and there are 7 days in a week. So this pattern of the weekends causing the problem is a 7-day pattern. 3 is another prime number. So we get this really erratic set of numbers. But if we look at a 7-day moving average, we get a really smooth picture. So this is the sort of thinking we do when we've got the observational data. It's not necessarily going to be absolutely right, remember. So the true observational data would have been that the number of deaths were not impacted by the weekend, but the observational data, when deaths are recorded and they're entered into the system, is more erratic. So we use moving data to make it better, to make it easier to interpret. So the final recommendation, my final tip, is to use say-do grids. There are differences between what people say and what they do, and it's really important to know about those and to understand them. So what do people say in one direction? What do people do in the other direction? I'm going to give you a couple of examples. Again, this is from some work I was doing in pharma many years ago. When doctors prescribe opioids, really strong painkillers for people with things like cancer and so on, they are supposed to check that they're not becoming constipated. And so doctors were asked, do you check regularly? And they tended to say yes. However, from the scripts, the prescription scripts they write, you could see that many of them almost never prescribed laxatives and other prescribed laxatives quite frequently. So we could see that there was a clear difference. People were saying they were doing it, but actually a lot of them were not doing it. So it's in the left-hand scale. So if we wanted to change behaviour, then it wasn't going to be useful just by asking people if they were doing it, because they weren't at the moment. And in fact, this was some research which was looking at bundling the laxative into the opiate drug itself. So the same drug would have both features. We could also look at some people who say, yes, I buy ethical products, and see how many of them buy Apple products, which are amongst the least ethical around in terms of that zone. And there's quite a lot of people who will talk a lot about wanting to be sustainable and wanting to source things ethically. And if you look at their purchase patterns, they're going to be down in this category. So these sorts of grids where there is a clear difference, a dissonance between what people say and what they do, can be really important if you're trying to make changes. So those are the 7 tips. What's included, what's missed? Define the granularity. Remember that what isn't why. Think about the causality. Try to avoid the lamppost phenomenon of thinking that the data you have is the right place to be looking. Make those patterns easier to see in the data, and create say-do grids so you can see if there's dissonance in what people are saying and what people are doing. And with that, I look forward to questions.